Easy if you listen. Really, I'm not kidding. It'll be really easy if you listen. That's up to you. So, today what we're going to do, our objective is simply to find an angle theta on the unit circle. Okay, write that down. We're going to find an angle theta on the unit circle. Okay. All of these figures are in your calculator, but by doing the unit circle, you start to really understand trig better. So that's why we learn the unit circle. It gives us a better understanding of what trigonometry does. So if we're going to find the angle from the unit circle, let's take a look at the unit circle. Okay, these are my angles. 30 degrees, 45, 60, 90, 120. These are the angles. So these are the answers we're going to get. Okay? Pi 6 is an answer. It's in radians, okay? Pi 4s, pi thirds. These are also angles, so these are going to be our answers also. We're going to just list both because, you know, having practice on both unit circle, degrees, and radians is good, okay? So now, here's what we do, okay? We know that sine of an angle is equal to the y value. We know that cosine of an angle is the x value, and the tangent is the y value over the x value, okay? And we have that on our unit circle. I mean, it's right up here. It says so, but it's nice to take a look at it again. Question 1 says this, in words. Find an angle that has a y value of 1/2. That's what it says. We're looking for an angle, but it's a sine value. We're looking for sine. Sine is the y. So looking for some angle that has a sine value of 1/2. Well, all right. I'm going to look at my unit circle for that, okay? There will be oftentimes two answers. We only want one answer, okay? So if I take a look at my unit circle, looking for a y value of 1/2, okay? So every point's x, y, it's there. So 1/2 is here, but it's also here. So there's two answers. We can only have one answer. Can't have two answers. It would not be a function. You have to have only one answer. So the angle is either 30 degrees or 150. The angle that's closest to the origin is 30, so the answer is 30 degrees. So theta equals 30 degrees. Or pi over 6. Same angle, different name. I want you to put both so we get used to radians, okay? 30 degrees or pi over 6. Example 2. We're looking for an x value, right? Cosine's an x value of square root of 3 over 2. So I look at my unit circle, square root of 3 over 2. X value is here, and it's also down here. So either it's going to be 30 degrees or 330 degrees, but I don't want to go 330 degrees. So the answer has to be 30 degrees. The angle we're looking for is 30 degrees. So theta would be 30 degrees or pi over 6. I want you to put both. I want you to put both the degree and the radian. Same angle, different name. How am I doing? Now tangent. We made tangents easy. I made my tangent values in pink, right? So I'm looking for a tangent value or some x over y that has a value of 1. So I'm looking for, which would be some y over x. And fortunately, we did all of those calculations throughout our unit circle to make it easy for us. So I'm really looking for y over x, which equals 1, and it's right there. And it's also here. It's both spots, right? We want the one that's closest, either 45 degrees or 225 degrees. The one that's closest is obviously 45 degrees. So my angle theta is 45 degrees, or the radian, pi over 4. Same angle, different name. One's radians, one's degrees.
How much do you want for that one?
You can, when I'm done, you can have my unit circle, okay?
Yeah.
All right, I'll make a copy of it for everybody who needs it, okay? You like my colored one, don't you?
Yeah.
Yeah, okay. I do have another one of these. Of course I do. Example 4. So we're looking for a y value, right? Y value because it's sine. So where's a y value of 1? 90. It's actually the only place. So actually the only place is right here at 1. It's the highest point, so it's 90 or pi over 2. So theta is 90 degrees or pi halves. How am I doing? You guys getting it?
Yeah.
Okay. Cosine is the x value. So let's find an x value of negative 1/2. X value of negative 1/2. 120 and 240, I believe, right? It's both, but which one's closest? 120 is closest. Everybody agree with that? So my angle theta is 120 degrees, which is the same thing as 2 pi thirds in radians, right? Or 2 pi over 3. Same angle, different name. One's in degrees, one's in radians, okay? Example 6. So we want to find a y value of 2. It's a trick question. It's impossible. It's impossible. Why is it impossible? I can get to 1, but to get to 2, I'm off the circle. Does that make sense? In fact, even on my calculator, if I did the sine inverse of 2, I get an error, okay? So sine can't be bigger than 1, can it? The sine value. So it's undefined, impossible. Okay, here's the one we did. This is why we ran. This example 7 was the whole reason we went outside, okay? So, negative 1/2. Find a y value of negative 1/2. Do you see it? It's here or here. All right, so we could run all the way to here, right? We could run all the way around to here, or we want the one that's closest. So we go backwards. That makes sense? We go backwards. It's got to be a negative 30 degrees. So theta is negative 30 degrees, or negative pi over 6. Same angle, different name. Yeah, Madison?
What if you have to choose between something like 30 and yeah.
30 is closer.
Well, I mean, sorry, not.
How about 30 and negative 30?
Yeah, that's what I mean. What if you have
Always take the positive.
Okay.
Always take the positive. Great question. I was wondering if somebody was going to ask that, because it's a really good question, Madison. We're going to find out why that's true tomorrow, okay? Now, let's keep going. Tangent. We got my tangent values, right? Negative square root of 3 over 3. Where do you see tangent negative square root of 3 over 3? It's right there, right? And it's also here. It's both spots, right? Which is closer? Negative 30, right? You guys agree with that? Negative 30 is closer, so it's going to be theta is negative 30 degrees, or is a radian, or negative pi over 6, okay? Now, calculator in radians. Now, we need an answer in radians. Okay, this is going to mess up my geometry, kids, but I'm going to let them know. So what do I do in radians? I have to use my calculator. What am I going to do? We're going to change our mode. Change our mode. Okay. So I'm going to go to my mode button, and I need to do it in radians. So my angle's in radians. So now we're going to use we're actually going to do radians. Okay. So change it into radians, and then if I want an angle, you have to hit the inverse button. Correct? Anytime you want the angle, you always push the blue button, right? So we're going to take sine inverse of 0.56 will give me my angle. All right, sine inverse of 0.56, and I can answer about 0.59, okay? That's an angle. That is an angle. It doesn't look like an angle. That is an angle. So let me show you what happened, okay? You have on your unit circle, these are angles, okay? These are angles. This angle right here, what's the decimal of that angle right there? What's the decimal of that angle right there? Come on, what's the decimal? You guys know what that is? 3.14? That's an angle. So 0.59 might be around here somewhere. It's an angle. Even more so, the y value of 0.56 is right about there. Height of 0.56 puts the angle right about there, okay? Right now, how about tangent? So we're going to do, I want the angle, I'm going to tangent inverse of negative 0.45, right? I'm going to use my calculator, and I'm going to go tangent inverse of negative 0.45, and I get an answer about negative 4.2, okay? That's an angle. Negative 0.42 is an angle. It doesn't look like an angle. It seems like the weirdest angle ever, but you remember that if 1 radian is about here, right about here is 1 radian, right about there is about 1 radian, then negative 0.42 radians is probably around here somewhere as far as radians. It's an angle. It doesn't even look like an angle. That looks like a decimal. But it's an angle in terms of radians. Weird, I know. This is like something it takes a couple of years to get used to radians. Honestly, a couple of years to get used to radians because they're weird. Okay, now what about example 3? Okay, so again, I'm looking for the angle. I'm going to go cosine inverse of 1.3. Okay, so I'm going to go, cosine inverse of 1.3, and I get an error. How come? Why did I get an error?
Because it can't be greater than 1.
Yeah, so if I take a look at my unit circle, here's my 1 for cosine right there. You guys see 1 for cosine? 1.3 would be out here, wouldn't it? Which doesn't put it on the unit circle at all, so that's undefined. Nice job, Giselle. Okay, that's all I have for today. What do you think? Wasn't that pretty easy? Okay, in our homework, I'm going to give you your homework to you in a second, and I want you to work on it.